Welcome to part 4 of my Unreal Engine tutorial for beginners. Since the last session, Unreal Engine has had an update from version 5.5 to version 5.6. So what we're going to do first is update our project to use the newest version of the engine. To do this, we go to the folder that contains our project. Within that folder, there will be a U project file. We right-click on that, go to Show More Options, and then we will see Switch Unreal Engine Version. Once we select that, we can use this drop-down to select the newest Unreal Engine version. If you do not see 5.6, then you first need to install that engine version on your computer. You would go to the Epic Launcher, and in the library, you would add a new engine version, find the newest one, and install it. Once we select the newest engine version, we just hit OK. Nothing will happen, but when we double click on the project, it should show us that it's going to load it in 5.6 right here, Unreal Editor 5.6.1. That will be all we need to do until we're at a point where we have C++ code or plugins that may need to be recompiled. For this tutorial series so far, we do not have anything like that. So it will just recompile some shaders using the new engine version, and it will load up just fine. So where we left off last time, we were working on this switch. We have it working so that when the player overlaps the switch, it controls the doors. Let's just test that again. When I get within the switch's collision box, the door triggers and keeps opening and closing. What we want to do is create some sort of interaction where the player goes near this, has a pop-up widget that says interact, press the F key, and the player can press that key and the door will open upon key press. So there's a few pieces here, and we're going to use interfaces to do this. Let's get our input working. Go to the input folder under actions. Currently, we only have 3 input actions, and these we stole from the third-person character template. The jump key is similar to what we're going to want to use for our interact. It's a Boolean where you press a key and it does an action. I'm going to right-click the jump and duplicate that and call it interact. Let's open that one up. We can see here it's a Boolean. It will trigger when the key is pressed and when a key is released. That seems to be the standard method. This way we can detect when the key is down and when the key is up. Really, this is about how we want it set up. We don't want to change anything here. Now that we have the interact action, we go back to the input folder, to our mapping context, double click on that, open up the mappings, and we're going to add a new one. Add IA interact, and then hit this little arrow, assign it the F key, search for F. Let's add another one here, search for face. On a controller, maybe it would be face button right. So that's really all we should need to do. Now that it's in our mapping context with some keys set up, we can start giving that a test. Go to our character blueprint, open that up. Let's go to our input graph that we had set up previously, and we'll add a new one. Right-click in here and search for interact, and we can see under the input section, IA interact. The way we set up the interact action, we saw that the triggered will be on press and release. So this is, anytime it's triggered, it'll come off of the triggered event execution pin here. Do a little print string and just say interact. Make it last for maybe 10 seconds. Trigger that. If we expand this, there's a whole lot more execution pins. As a test, we can see by pressing the key which ones will be used. You can just set some strings here, and this helps debug these inputs. Inputs can get very complicated depending on what you're trying to do. Do that for now and go in here, hit play. Now if I hit the F key, I just tapped it one time, and if I tap it real quick, it started, it interacted, and the Boolean is true. So using these print strings, when I press the key, we get one firing from here, one firing from here. Ongoing will trigger for however many frames the key is pressed, and the Boolean will be true. Then upon releasing, we'll get one trigger from completed and one trigger from triggered, and the Boolean will be false. And we can use all these things to do different things with our game. It's a way to create different types of interactions while reducing the amount of keys that you need to use. Use the started event because we really just want it to fire when we start the key press. And it'll only fire once when the key is pressed and then released. If we did triggered, it would fire 2 times. Ongoing will fire many times. We could use completed if we wanted to trigger only when the key is released. Started or completed are both viable options for our situation right now. I have one print string here, hit the F key, so I pressed and released, and interact only shows 1 time, which is what we want. We don't want to fire it more than that. At this point, we want to set up an interface that will be able to communicate with actors we can interact with. Let's go back to the root folder here. I like to put interfaces in my blueprints folder. So I would go in here, make a new folder. Let's call it interfaces. Open that folder. Right click anywhere, go to blueprint, blueprint interface. BPI for blueprint interface _ interact. Open up this interface. An interface is simply a collection of functions. And right now we have a new function, as it's called right here. I'm just going to click on it, hit F2, and rename it to interact with actor. Something like that. Being a little more descriptive will benefit us here in the long run. We could probably leave it just like this, unless we're intending to pass along some data. So what an interface is doing, we're going to add this interface to an actor, for example, the switch, and it's going to inherit all these functions that the interface contains. When we add this interface to the switch, we'll have interact with actor as part of it. Another function we may want is to grab some data from the switch to pass it along to the player character. We don't want to combine that with this function. This function is going to go from the character to the switch and perform an action. But before we use this, we may want to display some data in a widget or something. So I'm going to hit add and do another function that says get interact information, info or data, something like that. And what we do here, we may want to pass a struct that contains data of the interact actor. For example, the name of it. By using a struct, we can expand it in the future with additional data without having to come in here and edit the function. So let's just create a struct real quick that we can use with this. Go back to tutorial level and we'll stick it in the data folder, create a new folder here, and I'll just create a structs folder. Open that up. We're going to do a new blueprint structure. In my games, use just S for structure, but that's already taken by static meshes. Epic Games, their naming convention says to use F. So you can start it with like an F for structures. So it's really however you want to name it, what you're going to remember. To align with Epic's naming convention, I will stick with F in this project. So F, interact, actor, data. Then opening it up, this is how it looks as default. Structs are a collection of variables. The nice thing about structures is you could have arrays and maps and all kinds of variables together in a big collection. And then the structure becomes its own variable that you can have other possibilities as well. It could be used in a map or an array. And when you pass a structure from one actor to another, you're getting all of the variables passed together, and it keeps things easy, clean, and a little more modular. If you create a payload for something, it's basically a structure with a bunch of variables and stuff like that. Start out with this interact actor data. The theory here is it's data about the interact actor that will be passed to the player or player controller and displayed in a widget or something. It might also be used as quantities or resources that need to be spent to interact with the actor. We can get fairly advanced and in-depth here. First thing, create a text. The text is going to be the interact actor's name that displays in a widget. And we use text when it's a localized field. Player-facing text, we might want to localize it into different languages. And you can see the pop-up window there says a localizable text string. Name is more of an ID, a name for an object. It's for the code side of things. It would be the name of like assets and objects in the engine. Names are very efficient in the code, the way they're stored. Strings are inefficient. You can do complex things with strings, like search them and split them apart. So in this case, we'll make that text, and we'll call this actor name. Let's create an actor description, and I'll keep it text for the description because I would want it localized as well. And then let's call a resource. A resource might be what's required by the character to have in their inventory to use this thing. And we created a resource enum, I believe. Our resources are technically collectibles or naming convention issues here, but I'm going to put my collectibles enum here as to select maybe a type of resource or collectible that is required by the character. And then maybe we also want a resource quantity, and this could simply be either an integer or a float. I'll just stick with integer. So now we have this structure that contains 4 variables. We'll stick with that for now. That should be enough. Back in our interface on the getInteractInfo, we want to output that structure when it's called upon. We'll just call this payload, and we'll look for the interact actor data, compile that, and save. With this interact actor, we could have like an input or an output. You can get very fancy with this. I'm in the BP lever. I'm going to go to the source interact actor here. So right now our base interact actor is very simplistic. We'll add the interact interface, and that will give us those 2 events on all of our interact actors, including the buttons, which could come in useful in the future. If you're overlapping the button, maybe we want to see some of that actor data. So to add the interface, we go to class settings up here. On the right side, we have interfaces. We have no inherited ones, and we're going to add BPI interact. As soon as I do that, now it's in the list, and I have these 2 functions in the interfaces list over here. Compile and save that. We're not actually going to do anything in this base class with these interface functions. Close that and look at lever. It now has the interfaces because it's inheriting them from here. And if I go to class settings, they should be in the inherited list because they're inherited from here. And you can also add additional interfaces strictly to the lever if you want, or the buttons, and it can get pretty complex. Currently, when the player is overlapping the sphere, we cast to the character. What we want to do instead, disable that functionality. So we're not going to use either of the interfaces just yet. Right-click down here and do custom event. Interact with actor is our event. And when we interact with an actor, we want to get a reference to that actor. Add an input, call it actor, and in the type, do actor, an actor object reference. We're going to get the reference to whatever we're overlapping with, and you only want to interact with one thing at a time. I'm going to create a variable of this, call the variable current actor interaction, something like that, where it's the actor I want to currently interact with. When you hit the interact key, you only want to affect one thing at a time. So this variable is going to be that thing. If the player is overlapping many things simultaneously, this is going to be set to the last one that triggers. And upon interacting with that thing, we can do a check that sees if we're overlapping other things, then set this to the latest of the other things and have a way for them to interact with a lot of things quickly, but still one at a time. Once this is triggered, we also want to trigger a widget that pops up and says that we can press a key to interact with this thing. What we'll do is just print a string and say, press F to interact. This will take the place of our widget right now. Eventually that will be on the player controller and we'll trigger the widget to display from there. And before we do that, this is where the interface comes in. We'll get interact info, BPI interact function. Now, the cool thing with interfaces is to get this function, I do not need to cast to anything. It just shows up in any context menu, and I can plug in any reference to the target, and it's going to try to run this function on my reference. And if the actor does not have the interact interface implemented, it's going to fail quietly and not do anything. But if it does have the interact interface and we can get some information, then it will do it. In most cases, this probably doesn't need a check because we're going to call this from interact actors only. But if you need a check, you can do implements interface, and you can check if it implements the interact interface. And if it does, we can continue on. Actually, I might want to put this in the very beginning here. If we do something like this, any actor can cast to our character and call this function. Let's just do a print string off of here. Let's append and say actor. We'll put a space, does not implement interact interface. And we can make this a reddish color, have it for like 10 seconds. So now when we're working on our game, if we're calling this function, but the actor we're calling it from does not have the interact interface, we will have a little notification that we need to fix that, and the rest of this will not trigger. But if we do everything right, it's going to flow along just nicely here, get the info, and eventually we'll pass the info along into a function in the player controller that takes that data and puts it into a widget so that we can display that to the player. This will be actor interactions. Compile and save, go back into our lever. One thing to note with interfaces is because this function has an output, it's set differently than functions that do not. Double click on it, and it is a function like this. It's not an event, whereas interact with actor is an event because there's no outputs. Once we double click it, it turns that interface function into a implemented function. It goes up to the list here. What we probably want to do is just drag off this and do make payload. And then we can just fill this out and say lever, use the lever to open and close doors. And we're not going to use any resource, but we might gate some of these actors behind resources in the future. So that event is implemented, and when we're in our player character and we get the payload, that stuff will come over and go into a widget. Back in our event graph in the lever, we want to call the interact with actor from the character, and we want to pass self into the input here. Self is going to be the blueprint actor we're in, so BP lever will go into this input. That input comes out here. We will test BP lever to see if it has the interface. Then we also set our variable that we're currently interacting with BP lever. Then we will get the data from BP lever using another interface call, and it all simply flows. If I just leave it like this, compile and save, and then hit play, we can run over to the lever, and what we should see is the print string that says press F to interact. So we can see that that's working. The interfaces are being triggered. So again, we're calling a function from the character, and it's flowing through and saying press F to interact. Going back to our input graph, down here, we can get whatever our current interacting actor is and call the interact with actor message, the interface. If I hit F, we only want to do anything if this variable is valid. At some point, we want to clear this variable to stop interacting. Otherwise, we'll be able to interact with that lever from across the world, and that just doesn't really make much sense. Go back into the lever and implement interact with actor, double click it, and it creates this event. And we're going to tie this to the open and close stuff we had before. And we should be able to just keep hitting F and flip-flopping between open and close. So let's test that out. On, off. So I just keep hitting F and it's working. Very cool. But if I run all the way over here and hit F, it's still opening and closing the door. So we need to fix that. We need an end overlap. So sphere, come down here to end overlap and implement that. We'll basically copy this down like that. Other actor. In our first game character, I want to use a function for clearing the variable. Clear, interact, actor, something like that. Have an input of an actor object reference. If this equals this, then we will unset the variable. In a situation where there's many interaction actors, if I was to simply just clear the variable, we might be clearing a different actor from this, and then the player can't interact with something that they expect to, and it just wouldn't make any sense. We only want to clear it if we're ending the overlap on this particular actor, and it matches the current actor that the player can interact with. We don't want to falsely clear the variable. We're going to call this function clear interaction. Clear interact, just like that. Plug in self right here. Compile, save, compile, save. That should just work. Interact with the door, walk away, and I'm pressing the button and nothing's happening. And then I walk back up and it's working again. Let's say two of these were like close together. We'll test some edge cases here and see what's happening. This is lever 2. Maybe this door will be open and closed by lever 2. Overlap this. That door is opening and closing. If I go over here, now this is the most recent interact thing that I overlapped, and it's controlling that door. And it's pretty much working as I expect. It's a little funky because of how close these levers are. This is where some game design needs to be put into action so you don't run into this edge case, but you can be closer to the right lever, but it's still opening the left door because of how the overlaps, they were both triggered at kind of the same time, and I'm not ending overlap on any particular one. By keeping the collision spheres away from each other, we shouldn't run into any edge case where you can be closer to one and continue interacting with the other. That kind of solves that problem. Move them away slightly. There could be a wall here, or we can even shrink up the collision sphere. We would avoid those small edge case type things. Another thing we need is the lever to actually move up and down. We do need to change the pivot point of the lever. If we go to modeling mode, create a cylinder, radius. That kind of looks the same. So 5, 50, accept that the way it is, we can see the pivots on the bottom, which is what we want, as opposed to the current lever where the pivot's in the middle. So hit accept, find this in our thing, S, lever, double click in. I think we're using a button material here. The pivot's kind of on the wrong side compared to the dark shading. X-form, pivot. We're going to make it the top, hit accept. We're basically done with modeling mode. Go into our lever, replace this with S lever, unparent the lever so that we can fix the scale. It's kind of getting messed up by the plate here. Slow down that camera. Maybe 3, something like that. Parent it back to the plate and it'll keep the settings like that. Then what we're going to do is animate it so it rotates kind of like up and down like that. It's going to go from like -50 to +50. Kind of looks good. Default will be off. So down here at -50, event graph, custom event, switch lever. Timeline usually makes the most sense for this type of animating. Add a timeline, move lever. I can either create 2 events or I can put a Boolean in this. Let's do the Boolean method this time since we haven't yet. If the switch is on, we'll play there, and if it's off, we'll reverse from end. I always want the lever to go all the way up or down, so I'm using start and end. If you want the lever to be able to like go halfway or stop mid-switch, you would want to use play, stop, reverse, but that gets a little more confusing. Go in here. It's got to be a quick switch. We want it to be like a 1/4 second. Add a float. I don't want the switch to take too long. We'll just keep it linear. It's just going to be a quick flip of the switch, very fast. 0.25 might even be longer than I want. We can rename the track to alpha, and let's get the lever. Set relative rotation. We're only going to affect the Y. Lerp. Alpha goes in here. When the lever's turning on, it's going to go from -50 to +50. And when it's reversing, it's going to go from +50 to -50. That should be about it. Now we can replace these print strings with this function here. Switch lever. We're switching it on. And this one here, we're switching it off. And let's just see how that works. Delete my modeled lever there from the world. Also, going to where this lever is located, I want to move it to my meshes folder. Is this door being used? It's part of our door. We'll move that there as well. So it's with the door frame and stuff. Just a little cleanup. When I was messing with the lever, the sphere became gigantic. We gotta put this back to reality. I kind of want it to be something like that. Okay. I might want to make the sphere bigger. It seems too small right now. 64, let's try times 1.5. Let's see how that works. A lot of it's game feel, like what just feels good. I'm pressing F, and as soon as I'm about here, I controlled it once. So that's working really good. And then right there, I'm too far away. As a player, I kind of expect I'd still be able to interact with it, just even though it doesn't look right. But when I'm running up like this, I feel like I should be able to control it, even though the character is somewhat far. Go to 128. I think that's about as far as I want it to be. So that feels pretty good. It's all in the feeling. That's about what I expect when I play a game. I'd want to be able to control the lever from here, and that's working very nicely. The last piece to this is the widget that tells us to interact with this thing and gives us some information on it. Let's start off by creating a new widget in our UI folder. This will be part of the heads-up display. So in our HUD folder, right-click, user interface, widget blueprint. User widget is the option here. W, interact. Open that up. Let's start with a size box. Type that up here in the palette. Get a size box. Instead of fill screen, we are going to do desired, and then width and height overrides. Let's see, the width, start with 150, height 50. Let's make the width 250. In the size box, do a border. Within the border, do a text with the border highlighted. Let's do rounded box, a little fancier. We could change some settings here. For rounding type, change it to fixed radius. We have a little more control over the corners. Something like that. I'll do 15. I want the background to be tinted darker. I'm going to do black with an alpha of maybe 0.6. For the outline, I'll make it white. We want to use brush transparency, otherwise there's issues with how things fade in and out. Width of the border, 0.5. I'm going to go down to 0.4 on the alpha here. Text block, with that highlighted, let's center it, and it's justified more to the top here. I want it to be a little more padding on the top to get it centered. Let's try 6. The font, you have a couple options. I'm going to use Roboto Tiny. Interact. Right-click on the text and wrap it with a horizontal box. Then I'm going to add another text box to the horizontal box, and this one will be my key, which I'll use F, center that. This will be fill, some more padding on the left for the text, some padding on the right for this one. I'm hard coding in the keybinds with this project. That's an advanced topic I'll not cover here as it's fairly tricky. My suggestions for changing keybinds would be to start with a plugin that does it for you. Hard coding in the keybind will be as far as we go. In window up here, turn on the animation panel, add new animation. We'll just call it fade. Add the size box to our tray right here, hit the plus sign, and render opacity. We'll start it at 1 so we can see it, and in about maybe half a second, it will go to 0. So then we can fade in, fade out. To control this, we need to set up an event in the graph, remove all that, drag in fade, custom event, fade widget. We can have a little boolean here, fade in, hold B and click for a branch. If we're fading in, we'll do play animation in reverse. It'll be set like from here, and it'll go in reverse to fade in. If we're fading out, play animation forward. We also want to set the default position. We want to do a pre-construct. This is before the widget is constructed. We're going to set, we got to make the size box a variable, call it size box. Render opacity will be set to 0. We actually want to do this on construct. Pre-construct will affect our editor. So if I compile it, it's gone. We want to be able to see it in the editor. So construct will do it. So that is a simple widget with a fade in and out control. We want to put some details of the actor we are interacting with. And right now we had set up a few fields, such as the name and the description. Wrap the horizontal box in a vertical box. Let's get another text box. Drag it onto the vertical box. Make it go up. Now the size, instead of overrides, we'll do minimum, and then we'll uncheck those. Now it will grow based on what's in here. This first one will be a variable, and this will be the actor name. One more text box. Hit this arrow, tiny as well. Let's change the text size to 24. This could be the description as a variable. Last thing, on this horizontal box, we can right click and wrap it again with a widget switcher. That'll be a variable. I called it interact switch. What this is going to do is when we can interact, we'll have interact. But if we can't interact with it because we require a resource, we'll do another level. It'll have to be a horizontal box. So we'll just duplicate it. And within this horizontal box, as a placeholder, this will just be resource. And I'll put some brackets there to let me know it's going to change based on some variables. Maybe the size is a little smaller, maybe 16. Align vertical. I could have done that before. I missed align vertical. And then the quantity, let's say this will also be the same size. Align vertical. This will be a number like 1. I think I want both of these more closely to each other. I want to, instead of stretching this out, I want to center align these and get rid of the padding on the number. Let's get rid of the padding on the text. And this resource could just have a colon and a space so that it looks something like that. So when we're able to interact, it'll look like this. Maybe the font should be a little smaller. Justify center with this entire horizontal box. Let's pad the top by like 10. Actually, instead of on the box, let's do it on the switch. Justify the top by 10. Now that I'm looking at it, let's do it like this as well. Get rid of the padding on both text boxes. And I think I want the key to be surrounded by brackets. Maybe put a space in there so it looks something like that. This will be actor name, actor description. Make this 20. And then the whole thing can fade in and out. So what we need to do to populate these fields, custom event, show, interact, and this event is the one we will trigger to show this widget. As an input, we will call it the payload, f struct, f interact actor data. Pull off there, we can break it. We want to set some of these fields. So we have the actor name, pull off the node, and we will set text. And it's going to be set text with text here in parentheses. So the actor name will be this name. And then the description, set text, will be the description. If there is a resource, we need to parameterize this here, resource quantity. Back into our event graph, we'll go to resource, set text, pull off the resource, which is an enum, and we'll do enum to text. And then the resource quantity. You can also copy and paste the text field like that, save a couple keys. The quantity will just be the integer to text. And then get the size box and do a check on render opacity. And if it's less than 1, we want to fade it in. Even if it's like 0.9, 0.8, because the animation's playing, we don't know if it's fading in or out at that time. So anytime it's less than 1, we'll just say fade it in. We'll create a branch, plug that in to the branch. And if it's ever less than 1, we'll do fade in with the fade in checked. And if it's already faded in, the data on the interact widget will just update with the new information anytime we overlap different actors. We go back to the main content browser here and go to our main widget, which is our HUD, and we want to place it in here. So search for interact, put it on the overlay box, select it, center it, pad it a little to the left, and maybe 150, 150, so it's off to the side of the character. Go back to the tutorial level, go to the game folder, and let's check out the player controller. This is how mine is set up for now. We did this in previous sessions. We initialize the HUD. We can either initialize it on possess or do it on begin play. In the initialization function, we're setting the HUD, displaying our resources. In the set HUD function, we're creating the widget and adding it to the viewport and setting a variable. That variable is categorized here under UI. So we have the HUD variable already created and set in our player controller. We could leave it like this and just simply go to our character. And where we left off last time, we had created the player controller variable. We can drag it in, get the HUD main variable from the player controller, and then we need to get the interact widget from the HUD main. Then one step I forgot in W main, let's create this as a variable, interact widget, compile that, save, back in the character. Now we can click off HUD main and do interact widget. We'll get that. And then in the interact widget, we can now call show interact. So we'll drag off that and show interact. And then we have the payload right here, ready to go. Organize this a little bit. I like to stack these nodes like that to make it a little more organized. We have a function we had created clearing the interact actor variable. So that means we don't have anything to interact with. When we do this, we want to do the same stuff. We'll go to get all these nodes and copy them, and we will fade widget, and we're just going to leave it like this. It should fade it out. Compile and save this and test it. Now there are some errors. Access none, trying to read PC first game in the show interact. We only want this widget to appear if the player controller is valid. So we'll drag off and do a valid. If it's not valid, we will not have a UI at all. And stuff like this happens based on timing of things, or the other character that's in the level. This one here might be triggering that warning and it's not being possessed, so there is no player controller on it, which is likely the case. Let's see if that solves our issue. Also in here, we can do the same valid check. And then also in the lever, we have get interact info like this. Maybe we want to be able to change it. So what we could do is right click and promote to a variable, make it editable, expose on spawn, compile. Once it's compiled, we can come down here and fill in some default values, compile, save. Now we can edit the payload. This will be lever 1, do not touch, and this is lever 2. Let's check that out, save, test. Lever 2, use this one. Lever 1, do not touch. And the widget fades in and out nicely, and it's overlapping the character slightly. So to fix that, let's just justify that a little more to the right by padding the left. Now it's just to the right of the character like that. Go into the first game character, create another function, and this function, when we are done interacting with an actor, it's going to search the area around the character for another interactable that we are overlapping. This way we can change the target to that other actor if there happens to be one. What we're going to call it is find overlapping actors. And how we go about this is we're taking the capsule component, drag off it, and search for overlap. We can find get overlapping actors, and we can filter that down to only interact actors. Let's rename it to overlapping interactable actors. Find the BP interact. This is the base class. We're going to have a variable at the base class level, can interact, and we will leave it a Boolean. And if we go back to our lever here in the class defaults, toggle it on, and then let's right click BP interact and do a child blueprint. BP test item. We're just going to create a test item here. Might be something that's on the ground near a lever. Implement the info box, make payload, test item. This is a test. Implement the interact with actor function. Once we interact with it, get can interact and set it to no. We will print a string, got the item, and in class defaults, turn it on. Once we interact with it, we turn it off. What we could do, we can use a small timer here, half-second timer. So what this will do is for maybe a quarter of a second, we turn off the functionality that we can interact with it, and then we turn it back on simply so that our function in the character, when it's searching for another thing to interact with, it won't pick the lever right away. It will pick some other item that might be on the ground nearby, and the player is not struggling to try to pick something up, but this darn lever's in the way. It also gives us short delay on being able to switch the lever back and forth. For this to actually go into effect, we only want to interact when the can interact is true. And we'll do the same thing in the item over here. Now we have some sort of additional logic here, and we just need to go back to the first game character. We're going to find overlapping interactable actors. If we get an array of them, we're going to for each with a break. Now what I want to do is try to avoid casting. So I don't want to cast to the interact actor and get the can interact variable. I don't want to do that here. Casting will create a hard reference. We touched on this in part 1 of my series. And then every time my character is loaded into the game, it's always going to load in this actor, which for this very small game could be fine, but there's got to be a better way. So instead of casting, what we will do, drag off this not equal to our current interactor here. And if we create a branch, if this is true, we found something new to interact with, we can set that here, and we can create a local variable that says found new, and we will set that here. This local variable only exists within the function. We just need it temporarily. So if we did find something new, we can break the loop and then drag off completed, hit return, and we can take our found new variable and plug it in here. This will create an output. We'll just rename that found new actor to interact with, double click to create a reroute node and tidy this up a little bit here. And if we do not find anything different, it's going to stay false and we're not changing any of these. We also need to remove the item. Otherwise, we'll continue to select this item. So let's use this. This output needs to be a different name, found, question mark. There we go. When we clear the interact actor, before we do that, when we press the key, the input key here, once we've interacted with it, let's look in the area for another one to interact with, hit a branch, and if we did find one, we're going to call interact with actor, and then since we've set this in the function here, we will use that nearby actor to interact with. Right now, this is a test item, and I have pickups right here, a blank folder with the idea there would be items you pick up off the ground, and when you pick it up off the ground, you're going to destroy it after picking it up and add it to an inventory on the character. So that's the theory with doing these, or something spawns out of a chest and they land near this lever. We want to make sure we'd be able to pick them up without frustrating the player. Got an item, and got an item. The one thing not working is the widget is not updating. So why is that the case? Let's try putting the return at the end here. This essentially does the same thing and cuts the array short. Okay, now the widget changes. So I'm not exactly sure what the issue was here. The break wasn't really working. If anybody knows what I did wrong, feel free to let me know. But this seems to work, putting the return node here instead. As soon as we find an actor that doesn't match what we're already interacting with, we will process this and then just return the function. Then press it and then it finds an item nearby. Take the item, the levers overlapped again, and then we find another item. Could be some priority list as well created where items have priority over levers, but that's for you to expand upon. This payload could be converted into a data asset. Create a new folder and move all these collectibles into there. And then right-click, update redirectors, delete the unreferenced ones. Create a new folder for interactables. We can take the DA collectible and just duplicate it. So we drag it into the interactable folder, copy it, rename it to DA interactables, click into it, delete out all of these, change the variable to payload. This would be the F interact. And then in the payload, do some default values. If you get a warning compiling, try compiling it one more time and the warning may go away, or delete the variable entirely and create it with the plus sign from scratch here. Editing the mesh variable I had gave me a warning, but I just compiled it again and it worked. Then with that set, go to miscellaneous data asset using the interactable. This can be good lever. And then in our lever actor, we can change it to DA interactables. Object reference, change the variable type, cancel that search, get payload. And then it's already instance editable and expose on spawn. Get rid of that. So now we went from hard setting the payload by using make to having a custom variable to now having a data asset. And once we go into the lever, we can put good lever here and duplicate this, bad lever. Bad lever, don't use this. Lever 2 could be bad. Then we go here, try it out. It's now taking data from the data asset, and we can easily swap this data around without having to retype things into the individual assets. We just manage these data assets. And if for some reason we want to change something quickly, we can drag in the data asset and it will change it. In the widget, back in the UI HUD, our interact widget, in the graph, maybe this could be a function. Let's just add one of those and we'll check requirements. So we'll have an input of the resource quantity, and the resource will be that enum e collectible. So what we're checking is the quantity greater than 0? If it is, then we know we have to spend something to do the interaction. And this might even be a key for a chest. So if it's greater than 0, take the switch and set the index to 1, put check requirements right here and plug in resource. What we also need to do is check on the character if they have enough of the resource. Get player character, cast to our first person character. So before we switch, we probably want to check that. And on our player character, we have this map with our collectibles. We have to get this map and look through it. So let's just get the collectibles map, plug this in here. So what we will be searching for, the key, we want to find this resource. And if we do find a valid index, we take the values and we want to get a reference to those values, get the same index that we just found in the keys. And now this is the value the character has of that resource. We need to make sure that this is greater than or equal to what's required. And if it is greater than or equal to, the index will remain 0 and we can use the interaction. And if it's not, we will show that there is a cost that they do not meet. On the designer side, maybe we want this to be red, and maybe up here we want to show the resource as well of what they're spending. Let's wrap this horizontal box with a vertical box and then duplicate this horizontal box, get rid of those text boxes and paste in the ones we just copied. Maybe put this up and resource on the left. I do want this horizontal box to be a variable cost box. So this cost box has the resource. We don't want this to be red if we are good with it. Just make it white again. I think I want there to be a little bit of padding between these things. So maybe another 10 padding between these boxes. I think the text might be a little too small. Go up to 18. And the number here needs a little padding on the left side, maybe 5. I'll put padding on it here too. And what we're going to do, one last thing, is if the resource quantity is 0, we're going to take this cost box that we just created and set visibility to collapsed, which will just hide it. This widget is part of our HUD. It only gets created once, will persist throughout the game, just collapsing the visibility until the next interaction checks it and decides if it needs to be visible or not. If it does have a quantity here, we will set it to not hit testable. And that just means the mouse won't be able to click it, which can prevent the mouse from maybe clicking other things on the screen. For example, if you have an in-game menu pop up and this widget's in the way, it might block the mouse from clicking the in-game menu. Make it not hit testable to avoid issues like that. Add some return nodes. Not really necessary when there's no outputs, but it looks nice. Then it's plugged in right here, and we need this resource to go into it. So that's all on the widget side. However, we have not gated the actual interact. In our blueprints, interactable, the base interact actor, we have a can interact boolean. Let's just do something similar here. Check requirements. Same thing as before, 2 inputs for this function. We're going to have the resource, which is the collectibles enum, and then resource quantity, which is the integer. So whenever we need to check a requirement, we will be able to call this function and plug in those 2 things. And same as before, we will check if this is greater than 0. And if it is, we will check the character. And if it is not, then this will be checked, and it will end there. If there is a requirement, again, we can probably take most of this functionality here in our function we just created. Things can definitely be refactored here. I'm just flowing through this and going with it right now. We'll take all of this player character from the cast to the branch, and we're just going to copy that and paste it here. So if the quantity is greater than 0, we'll cast to the character, get the keys. We're going to find the resource. If we do find it, we will get the values and check it against the quantity that's required. If the character has greater than or equal to the quantity required, then we can interact with it. And if not, we will not be able to interact with it. Compile and save that function. I'll add these return nodes just for fun. Compile, save that. Now in our lever, what we can do is implement this function. It does not show here, but it does exist. So in the lever, we call interact with actor, and we will check the check requirements. And we just added a data asset to this actor to contain the payload. We can take the data asset, get the payload variable. We can break this and plug in the resource and resource quantity. If we want to hide the other things on the payload, and keep in mind this could have many, many items in it and might be ridiculously long, we can hide the unconnected pins so that it cleans that up. And if we ever want to show them again, you can come over here and check off what you want to see to customize it a bit. All right, with this here on the lever, we have this test item we can even implement it on. We do not have the sphere implemented with its own overlap event. We can quickly just grab this one here. A simple copy and paste will do it. Now when this test item is overlapped, it will do the same thing as the lever. And we can also put check requirements right here. And in the item, we didn't set up a data asset. We just created this variable. So we can use the payload and do the same thing here and hide those. Let's give some of this a test and see how it works. This lever here on the right, bad lever. Let's say it needs 5 coins. And let's take one of these test items, payload, call this test with cost, and maybe it needs 1 star. I made a little mistake here. If we do not find the collectible in the character's keys here, which is possible if they never collected the item, we also need to pull off and set the widget index to 1 because they just do not have the collectible. That's one missing piece, and we'll do that here on the interact requirements section here. We'll put this there. Another cleaner way to do this is just copy and paste this down here. That could be a little better. When there is no cost, we need to also set the switch down here, make sure it goes back to 0. Get the interact switch, set active widget index, set it back to 0. The problem that I did not account for was these actually do need to be variables, and maybe this could be set up a better way so that we do not need them here twice. I kind of just wanted to show off how widget switcher worked, but when showing, maybe instead of a widget switcher, the resource is always listed here, and we just have interact collapse or not collapse. Quick way to solve this is to make these variables and plug resource quantity 1 and resource 1 into the same exact box. So then the text for both of these will mimic each other. Get the stars, get the coins. Now we can use it. It does not deduct from our inventory or anything. That's probably a future thing. Star, I picked up the item, got the item. The widget's still a little messed up. In the designer here, this needs to be centered. The horizontal box was messed up. I just needed to horizontal alignment should be centered like that. That should fix it so that it doesn't look too messed up. Get the star again. And now that looks better. The star with the quantity is more centered. Other things to expand this would be creating icons for the resources and having a little icon and designing the UI to be a little better, but this is a start. Game design is all about iterating. The project file all the way through part 4 will be on my Patreon. Check that out if you would like to just download the project files. But I think for this segment, that will be it. I hope to see you in the next one. Take care.